Hi guys, thank you for joining. Can I ask if everybody can hear me?
Yeah, I can hear.
Okay. Okay, I guess I'll just start now. If you guys have any questions, right, you can ask me using the chat function and I can answer them. Okay, so thank you so much guys for joining me in this series of crash course. And today I've been talking about sharing some exam tips and some important concepts regarding electrolysis. And electrolysis is actually one of the most challenging topic in O levels. And as a tutor myself, I also taught a few students both O level and IP track, and I realized that the one of the weakest topic that they have in common um, is actually electrolysis, because it's quite confusing, especially at the later parts where they are wait, let me check. Okay, so I was just saying that electrolysis is one of the most challenging topic in O level and IB syllabus. So it's actually very, very important to have a strong concept and a strong understanding for this topic, because it's very, very likely to come out as a whole full question, 10 marks question, and even in MCQ. So if you guys have any question, right, just ask me in the chat function and I'll answer them. Yeah. So let's move on. Okay. So first we let me okay. So firstly, we have to understand what actually is electrolysis. So in one simple sentence, electrolysis is actually using electricity to break down chemicals that contain mobile ions. So let's break down this whole definition slowly. So the meaning of using electricity is actually using a battery. So it is fairly straightforward, and we can understand that to break down chemical, we have to use a sort of electric source, which is in the form of batteries in our syllabus. So using electricity to break down chemicals. So meaning of breakdown chemicals means that if there's a complex chemical, we are breaking down um, to simpler chemicals. So for instance, I prepared this visual diagram to let people to help you understand. So let's say we have one big circle. The meaning of breakdown means that we actually make it into two smaller pieces. So let's say we have a very complex chemical compound. What happens during decomposition or breaking down is that it forms two simpler chemical compounds. So this is the meaning of breaking down. So let's go back to the definition. Using electricity to break down chemicals that contain mobile ions. So this chemical that contain mobile ions in this chapter is also known as electrolytes. Okay, so this is simply the definition of electrolysis. Okay, so now we take a look at this electrolysis setup. This is the most simplest electrolysis setup, where over here we have a battery, which is the electric source needed for electrolysis to take place. Because remember, from the definition, electrolysis is actually using electricity to break down chemicals. And we also have the electrolyte. Electrolyte is simply a chemical that you want to break down. So it is usually very, very is a very complex compound. It's a big compound. It's not a simple compound. So examples of electrolytes, we have sodium chloride, aqueous sodium chloride, which contains a number of ions inside, which contains, for example, Na plus, Cl minus, H plus, and OH minus. This is a part I'll go in depth in the later part of this course. So to put simply, electrolyte is simply the chemical that you want to break down. And another key term that you need to know for this chapter is the electrode. What is the electrode? Electrode is the piece of metal over here. It can be metal or it can be graphite. So it's a piece of, it's a thing that we put inside the solution, connecting the wires and the solution so that the electric current can flow through in this closed circuit. So for this electrode, we can simply understand it as the broken down products that will be discharged over here. So this is actually a general explanation of electrode. And if we actually learn in the later part of the chapter, we will know that not all the products will be discharged at the electrode. And in some cases, especially if we are using active electrodes like copper, the electrode will actually take part in the reaction. So these are the things that I will touch later on. So one common question that exam papers will ask is that why must the electrolyte contain mobile ions? So actually, I realized that many of the students have difficulty understanding this question, and this is perhaps having a weak foundation for this topic. So I'll explain why. Okay, in this electrolysis setup, we know that this battery over here, and the battery is needed for this whole electrolysis to take place because we need electricity to break down the compounds. So there's electricity going through, right? So what actually drives, what is actually conducting the electricity? So we can separate up into two parts. So from this upper portion, the battery and the wires, we know that the electrons inside the wires are the ones that actually conduct the electricity. So in the wires, is made of metal, and metals, they have electrons. So the electrons will move and carry charge. So the electrons are the ones that conduct electricity in the wire. So you can see here, the electrons from this battery will start to drive the whole electrons, all the electrons in the wire. So the electrons will move over here. Electrons will move over here until it reach the electrodes over here. So how does electricity flow through to close the whole circuit? Because right now it is over here, right between the electrodes is actually the solution. So what actually complete the whole circuit is the ions in the electrolyte. So the ions over here are the ones that conduct electricity inside the electrolyte. So right over here, let's draw a boundary. Everything on top of this diagram is actually the electrons are actually the ones that conduct electricity, and right below this red line is where the ions are the ones that conduct electricity. So we have to understand why the electrolytes must contain ion, because they are the ones that close the whole circuit and make sure that the electricity can run through the whole circuit. So so over here, when we have the wire over here, electrons are the ones that conduct electricity. Okay. So what will happen when the circuit is closed? So what will happen during electrolysis? We know that over here, the positive terminal. The longer end is the positive terminal. The shorter end is the negative terminal. So right over here, if we extend out, this will be the positive electrode, and this will be a negative electrode. And what happened is the anions, meaning the negative ions, will be attracted to the positive electrode. So what will happen is all the anions will move to the positive electrodes. And when they move to positive electrodes, they don't just gather at the positive electrode. What they do is they lose electrons at the positive electrodes. So you can expect these negative ions, which is known as the anions, moving to this positive electrode, and they lose electron. So this electron will move up over here. So we can see this as the electric. We'll see this as a. If we view this as an electron flow, we can know that the electron will flow from the positive and upwards towards the battery, move from the positive electrode to the battery. So what happens when we have a battery over here? The battery will pump the electrons. So electrons will exit out this negative terminal and will go down to the negative electrode over here. And what will happen is that the cations will then move to the negative electrode. So the same thing over here, these positive ions will all move to this negative electrode. And what happened is that they will take in the electrons over here. So this sort of like close the entire circuit. So if we look back at this positive electrode over here, what happens is that electrons are actually deposited here by these anions. So we have many anions over here. Electrons are actually deposited over here, which actually flow through the external circuit down back to this negative electrode, where the positive ions here will receive the electrons. So we now have to understand what is the purpose of these ions over here. The purpose of the ions here is to actually take in and give out electrons so that they close the whole circuit. So the meaning of closing the whole circuit means that electrons can actually flow throughout the whole circuit without any interruption. So yeah, so this is exactly why we need mobile ions. So to put simply, why we need mobile ions? Why we need them to be mobile? Firstly, is because we want them to be able to move to the respective electrode. So that is the negative ions will move to the positive electrode. And the positive ions will then move to the negative electrode. Okay, so another thing is why ions and why not atoms? Why not mobile atoms? Because ions are the ones can actually move when there's an electric current. So let's say we have a battery over here. So if this is the positive terminal, this electrode will become the positive electrode. So it will sort of like attract the negative ions to the positive electrode. So that is why we need ions to be there, so that they can actually move to the electrode. So these are the reasons why we need mobile ions. We need mobile ions simply because we need them to actually conduct the electricity, to close the circuit, such that there's a flow of electrons. And now that we know that these chemicals, electrolytes, needs mobile ions, so we have to think of what kind of chemicals can be electrolyte. So there are three types of compounds or solutions that can be electrolytes, and in this O-level syllabus in particular, only these three will be in the syllabus. So the first one is molten ionic compounds. So let's have an example of molten ionic compounds, and the most common example is NaCl in the liquid form. So the meaning of molten is actually solid NaCl heated strongly until it turns liquid. So molten sodium chloride, for instance, contain two ions actually. It contains the Na plus liquid and Cl minus ions. So molten sodium chloride contains two ions, the sodium ions and the chloride ions. And I think we learned in a previous chapter that ionic compounds in a solid form okay, they have a crystal lattice structure. They have a giant crystal lattice structure where the positive and negative ions are arranged orderly. So this is what looks like in a solid form. So after they are heated strongly for a long time, these orderly patterns, this orderly arrangement is actually disrupted. So the heat will actually overcome the strong electrostatic forces of attraction between the positive and the negative ions. So what happens is that these positive and negative ions are no longer um, orderly arranged. So we can expect to see ions to have some spacing apart, and they are actually mobile because there are no attraction that holds them together. So they can actually move around very freely, and that is why we can actually use molten ionic compounds as an electrolyte, because we have mobile ions. Okay. Okay, so the second electrolyte that we often use is the aqueous solution of ionic compounds. So ionic compounds in the molten state and aqueous state can actually be electrolyte. And the reason why is because when we have aqueous solution of ionic compounds, what happens is that the lattice, similar to the molten one, will actually be broken down. So let's say we have NaCl and aqueous state, we put AQ behind. What we have is actually Na plus aqueous and Cl minus aqueous in the solution. And because it is an aqueous solution, it also contains water, and water actually dissociates very, very, very in a very small amount. So let's say we have water, it dissociates in a very small amount, and we use this arrow because it does not dissociate completely. It dissociates in a very small amount to produce H plus and OH minus ions. So in the aqueous solution of an ionic compound, we actually have 4 ions right over here. We have the Na plus, we have the Cl minus, we have the H plus and OH minus. And these ions together can actually help to conduct the electricity in the electrolyte. So it fulfills the criteria of having mobile ions. And the last electrolyte that is actually possible is acids. So acids, as we know, contains H plus ions and another anion. So these two ions are actually the ones that conduct electricity in the electrolyte. So let's say we have the most common example is hydrochloric acid. What we have is H plus ions and Cl minus ions. So from these three compounds or solution, we know that the main criteria that we need is having mobile ions, because they are the one that conduct electricity in the electrolyte. Okay, so explained previously why ionic compounds are electrolytes, because when they are molten, right over here, when they are molten, the electrostatic forces of attraction between the anions and cations are overcome. So they are free to move towards the electrolytes of the opposite charge. So what happens is that the positive cations will be attracted to the negative electrode, and the negative anion will be attracted to the positive electrode. So that is why ionic compounds in a molten state can actually be electrolytes. Okay, so here I will explain one more time using a diagram why aqueous ionic compounds can be electrolyte. So if we have, say, this ionic compound, which is initially in a solid form, and these are water molecules, when they are placed together, what happens is that the water molecules will interact with these ions. So these ions, when they interact with these ions, they actually give out energy. And this energy is actually strong enough to break these ions from this orderly arrangement. So this is actually part of out of this O-level syllabus, but it's good to know that it's good to know why water can actually break up this giant ionic crystal lattice structure, and it's because of the interaction. So water interacts with the ions, causing them to break off from the arrangement. Yeah, so this is why. So after the water break up with this, after the waters form these ions will be the one that carry charge in the electrolyte. Okay, so another question we have to ask ourselves is, what chemicals cannot be electrolyte? And these chemicals, what we know is that these chemicals must not contain mobile ions. So if chemicals that do not contain mobile ions, these chemicals do not contain, if the chemicals don't contain mobile ions, we know for sure that they cannot be electrolyte. So some of examples are solid ionic compounds, metals, and pure covalent compounds. So over here, I will explain why covalent compounds cannot be electrolyte, simply because they don't have mobile charge particles. So over here, we can see that this is a covalent compound. They are not charged. So right over here, we can expect the charge to be neutral. They don't have a charge, so they don't move when an electron when there's a battery placed in when there's a battery put in place. So they can't move and they can't carry charge. So covalent compounds are actually not electrolytes. Yeah, and over here we can see from second point, they cannot move freely towards the positive anode and the negative cathode electrodes. So covalent compounds cannot be electrolytes. So let us take a look at an example of electrolysis of a molten electrolyte. So let's say we have this molten ionic compound and they are no longer in a fixed position. They are not in a fixed arrangement. So they're sort of like a liquid. They can slide over one another, the ions over here. And when there's a battery put in place right over here, we know that this battery, the longer one, is the positive terminal. So this electrode is the positive electrode. And as discussed earlier, positive electrode will attract the negative anion. So what happens is that the negative anion will move towards the positive electrode. So anion will move towards the positive electrode, which is called anode. So positive electrode is also known as the anode. And the anion will lose electrons or oxidize to form neutral atoms. So not only will these anions just move to this positive electrode, they also engage in chemical reactions. So the chemical reaction they will do that will be happening there is the oxidation. So anion will actually lose electron to form a neutral atom. So we can see right over here, the ions become atoms, and the electrons will be on this positive electrode. And the electrons will actually move up to this battery, and they will cross over to another electrode over here. So what happens is that the electrode will the electrons will actually come to this negative electrode, which is known as a cathode. And because of these electrons over here, you will attract these positive ions right over here. And these positive ions not just go there, they will actually gain the electrons and reduce to form the neutral atoms. So this is what happens during electrolysis. So the negative, in summary, the negative anion will move to the positive electrode to form atoms, and the positive cations will move to the negative electrode to form atoms. So what's the purpose of the battery right over here? As I just now have mentioned briefly, the battery actually pumps the electrons from the anode to the cathode. So without the battery, the electrons will actually not move because they will. It is. I can't really explain in O level using O level concept, but we need a battery because this whole chemical reaction is actually endothermic. So we need an electric source to drive the whole electrons around the whole circuit. So let us take a look at the real life example right over here. So we have Na plus and Cl minus. So this is electrolysis of molten sodium chloride. So there's just only Na plus cation and Cl minus anions. So what happens is that the anions will move to the anode, which is the positive electrode, and they will lose electron, the go station from Cl minus atoms. So after they form Cl minus atoms, what another thing that will happen is that the Cl minus ions, Cl minus atoms will actually form Cl2 gas. So you can actually see bubbles of Cl2 gas appearing at this positive electrode. So Cl atom, chlorine atom will actually not form. It will actually combine together to form a diatomic chlorine gas. So right over here, okay, so electrons will then move up the battery to this negative electrode where the positive cation will be attracted to. So the positive Na plus will actually move to the negative electrode and will form Na sodium metal. So yeah, so this is what happens during electrolysis. So from Na plus, from NaCl, we actually form sodium metal and Cl2 gas. So this is actually what happens um, in electrolysis. So let me see if anybody have any questions. Okay, if you guys have any questions, do let me know in the chat. So yes, so the sodium metal is solid over here. Yeah, so the chlorine right over here, the chlorine atom will actually will actually combine to form chlorine gas. So sodium will be sodium will exist in a solid state. But one thing to note that because this is molten sodium chloride, so we can expect it to be very high heat because to make molten sodium chloride, we actually have to heat it to 801 degrees Celsius. And sodium has actually very low melting point. So by right, sodium at room temperature should be in solid. But at the process of electrolysis, it is because of the very high heat, it will actually become molten as well. So yeah, so we have to look at in context of the question, of the exam question. So if the question is asking what will happen to the sodium when it's cooled to room temperature, so the state of sodium will be in the solid, but during the electrolysis where there's a high heat because of the molten sodium chloride, you'll be in the liquid state, in the molten state. Yeah. So okay, so move on. Okay, another key thing to note is that electrolysis is actually an endothermic reaction. So to recap the meaning of endothermic means that this reaction actually requires energy, requires energy for it to be feasible. So so the energy actually comes in the form of battery. So we need to add the battery in the whole circuit so that this electrolysis can actually take place. Okay, so if we look at this diagram here, the energy profile diagram, we know that because it is an endothermic reaction, so the energy level of the reactants will actually be lower than the energy level of the products. So this is how you draw the energy profile diagram. And the enthalpy change over here is positive. So yeah, and the enthalpy change here is positive. And this is the energy given. This also the enthalpy change is actually the energy given by the battery. So the reason why this reaction can take place, this endothermic reaction can take place is because the battery supply the energy required. Yeah. So over here is the activation energy, and we have the products over here. So we have two Cl atoms. They combine to form Cl2 gas, chlorine gas, and sodium atom, and sodium metal over here. So these some of the exam tips that you must know lah, so that we can actually do questions very quickly and don't really make mistakes. So oxidation will always occur at the anode, and reduction will always occur at the cathode. So throughout the whole topic of electrolysis, these two statements, perhaps the most important statement that you must remember. So it's good that you memorize them, so that during exam, when they ask what kind of reaction, what is the redox, if the question actually asks you to explain the redox reaction for this electrolysis question, you will know for sure that oxidation will always happen at the anode. So throughout the whole topic, these two statements are true lah. So you must go and memorize it, so that you don't really make mistake during exam. And there's an acronym that you can actually memorize. So positive is always the anode, negative is only cathode. And this is only true for electrolysis and not for the electrochemical cell that we'll touch on in a later chapter. So this statement is true throughout the whole topic. So you must always remember these two statements, and this is perhaps the best exam tips that I can give anybody who is studying this chapter. Okay, so just now we looked at electrolysis of a molten electrolyte. So now we need to look at electrolysis of an aqueous electrolyte. Okay, so let us take a look at example of aqueous sodium chloride. So the setup is pretty much the same. We have graphite electrode, two graphite electrode here, and aqueous sodium chloride. So the main difference between molten sodium chloride and dilute aqueous sodium chloride is the ions present in the electrolyte. So in aqueous sodium chloride, what ions we have is the sodium chloride will dissolve in water to form Na plus and Cl minus. And because it's aqueous, it contains water molecules. So the water molecules will actually self-dissociate to form H plus and OH minus ions. So these are the anions present in the electrolyte. So these are the cations that are present in the electrolyte. And comparing it to molten sodium chloride. So let's say we have molten sodium chloride. What we have is sodium chloride molten, so we have Na plus Cl minus. So that's all. That's all we have for molten sodium chloride. So for molten sodium chloride, we have only two ions. And for aqueous sodium chloride, we have 4 ions. And because aqueous sodium chloride have more than because sodium chloride have more than one anion and more than one cation, so we need to actually determine which of the ions will actually be discharged at the electrodes. So let us move on. Okay. So what will happen at the anode? So we know that at the anode, so this is the positive terminal. So it will be the anode here. And this is a negative terminal. So this will be the cathode. So the anode will attract the anions. So the N ions over here, there are two N ions, is the OH minus and the Cl minus. So these two N ions will move to this electrode. So when two N ions move to the electrodes, only one of them will be discharged. So the negative charge chloride ions and the hydroxide ions are both attracted to the positive anode. So right over here. So we have, right over here, we have OH minus and Cl minus. So out of these two ions, we need to determine which one will be selectively discharged. So to know which ions will be selective discharged, we have to look at this series. So at this lower end of this series, so for hydroxide, they are the most easily oxidized. So it will be the most preferentially discharged one. So if let's say we are comparing between OH minus and Cl minus, OH minus will be the one that will be discharged, and Cl minus will just remain in the solution. So we know for sure that OH minus will be the one that is discharged and not Cl minus. And Cl minus, Br minus, and I minus, these three compounds will only oxidize if the solution is concentrated. So if we have a higher concentration, if we have a high concentration of Cl minus, so this square bracket is actually talking about concentration. If you have a high concentration of Cl minus, then Cl minus will be discharged. Okay, so if we have a low concentration of Cl minus, then OH minus will be discharged according to this table. So when OH minus is discharged, this will be the formula. This will be the formula for this discharge. So OH minus will actually form water and oxygen gas. So what we expect to see is that there will be effervescence of colorless gas. It's actually oxygen and electrons over here. So OH minus actually lose electron and is actually oxidation. And remember, this is anode, so it will always be oxidation. Okay, so because the solution is dilute and not concentrated, hydroxide ions are preferentially oxidized to form oxygen and water at the anode. So we can expect to see effervescence of a colorless gas, which is oxygen. And in most exam questions, they will ask, what do we expect to see if we, they will tend to ask, how do you test for oxygen? And this is actually part of another chapter. So we have to learn how to identify gas, because this kind of question, this kind of follow-up questions will be present in O-levels and even in IP exams. So we need to learn the test for oxygen, because it will be it will tend to come out for your exams. So now take a look at cathode. What happened at the cathode? Positively charged sodium ions and hydrogen ions are attracted to the negative cathode. So right over here, so in this solution, we have Na plus, Cl minus, H plus, OH minus. So these anions, these two anions will go over here, and the Na plus and the H plus will move towards this cathode, this negative electrode, which is the cathode over here. So we know that OH minus is preferentially discharged here. So now, since we have H plus and Na plus, so now the question we ask is, which cation will be preferentially discharged right over here? So determine which positive ions will be discharged, we have to look at this series over here. And this series is actually very similar to the reactivity series. So what is so how to determine is that so how do we determine is that the ions that are lower in this series will be discharged? So take a look at this example. We have Na plus and H plus over here. So Na plus will be over here, H plus will be over here. So since H plus is lower than Na plus, H plus will be preferentially discharged. Okay, so you can expect to see H plus being discharged. So when we have H plus, it will form hydrogen gas. So if we balance 2, yes, so we can actually see hydrogen gas, effervescence of hydrogen gas right over here. So this is how we determine which positive cation will be discharged. So, okay. So since sodium is above hydrogen in the electrochemical series, therefore hydrogen ions will be preferentially reduced to molecular hydrogen at the cathode. So this is what happens at the cathode. Okay, so now we look at concentrated sodium chloride. So just now we are looking at sodium chloride. So the only difference between okay, I guess I made a mistake here. This will be concentrated sodium chloride. So the main difference between concentrated sodium chloride and aqueous sodium chloride, the difference happens only at the anode. So anode is where the difference happens. So at the cathode, no difference. So this is a summary of the difference between concentrated and aqueous sodium chloride. So the meaning of aqueous meaning is dilute. So some questions may not actually put the word dilute over there, but you need to know that aqueous sodium chloride means dilute sodium chloride. So the only difference happens at the cathode. Happens only at the anode. And for the cathode, we will expect no difference. So we will expect the cation's discharge will be the same for aqueous sodium chloride and concentrated sodium chloride. So for this, so we take a look at the anode and the ions present in the anode. So the present ions present anode is OH minus and Cl minus. And from this series, we know that OH minus will actually be discharged. But we have to remember that we are talking about concentrated. So if the solution is concentrated, these 3 ions here will be discharged. And since chlorine is part of these 3, chlorine will be discharged to form chlorine gas. So the only, I think I have to repeat one more time for this is because it's very, very important. So the only difference between aqueous sodium chloride and concentrated sodium chloride is the only difference happen is at the anode, not the cathode. So with this understanding, it will be so much easier to do exam questions because you don't have to bother thinking about the difference that is happening to the cathode because the cations will actually not be affected by the concentration. So the concentration of cations won't actually affect the product's discharge at the cathode. So we only think about the anode. And we have to remember for aqueous solution, hydroxide will be preferentially discharged. But for concentrated solution, the halides, the chlorine, the bromide, and iodide ions will be preferentially discharged. And one thing to note is that sulfate and nitrates, these 2 ions will never ever get discharged in electrolysis. And the reason why is that because the bonds are very, very strong and it requires a very, very large amount of energy to actually break them apart. So it's actually, it's not very feasible to actually to allow these ions to be discharged. Okay, so because the solution is concentrated, chloride ions are preferentially oxidized to molecular chlorine gas at the anode. So yeah. Okay. So uh, another case of electrolysis is using copper electrode. And copper electrodes are actually active electrodes. They take electrolysis at the anode only, not the cathode. So if you have a question that uses okay, let me explain that later. So unlike graphite electrodes, which is inert, they do not take part in electrolysis. So the main difference between copper electrodes and graphite electrodes is that copper electrodes actually take part in the electrolysis reaction, and compared to graphite, they just act as they are just there to actually connect the wires to the solution. So they don't really take part um, in the electrolysis reaction. So let's say we have copper electrodes over here. The anode oxidation will happen. But without looking at anything else, I will know for sure oxidation will happen, because throughout the whole chapter, anode is where oxidation will take place. So copper electrode oxidized to form copper 2 ions. So this is where the confusing part comes in. So now is the copper electrode that is the one that is oxidized. Wait, okay, so copper electrode is the one is oxidized, and there are no ions here that will be oxidized. So this is the difference here. If you are using graphite electrode, ions are the one that is oxidized. But if you are using copper electrodes, which are active electrodes, the copper electrode itself, the electrode itself will be oxidized to form copper 2 ions. So this is how the reaction will look like. So copper solid will form copper 2 plus, and yes, 2 electrons. So this is the half equation right over here at the anode. So copper will lose electron, oxidized to form copper 2 plus ions. So this is actually what will happen. And even though there are N ions over here, so the N ions here are sulfate ions and hydroxide ions, but they will never get discharged, because this electrode right over here is active electrode. And over at the cathode, copper 2 ions will be perfectly reduced to form copper atoms. Copper electrode does not take place in any reaction at the cathode. So one thing to remember is that for this case, let's say if this is copper, we have two ions that's present at the cathode, and copper will be perfectly discharged. The reason why this is so, because it is lower in the electrochemical series. So if it's lower than hydrogen ions, hydrogen in the electrochemical series will be perfectly discharged. And one common question in exam is that what happens if we change this copper electrode to graphite and copper remain at the anode? So what difference will we have? There will be no difference, because the cathode over here don't take part in the reaction. So it will just remain there stationary. It will just it will not dissolve, or nothing will happen to this cathode. So regardless whether or not it is a copper electrode, or regardless is graphite or carbon, this cathode over here will not take part in any reaction. Yep. So this is something that is very important, and it may be very confusing if this is the first time you are hearing this. So we need to know that copper electrode does not take part in any reaction at the cathode, and this is perhaps a summary of the whole question. So if you are able to understand this sentence, it means that you really understand this subtopic of electrolysis using active electrode. And now is the last part of this topic, which is batteries. Okay, so let's look at this diagram over here. Let's say we have two metals, copper and silver. And from the metal reactivity series, we know that copper is actually higher than silver in position. So copper is actually much reactive than silver. So what happens is that when we have copper and silver, connected using a wire over here, what we expect them, what we expect is that the atoms of the more reactive metal will be oxidized. So copper right over here will be oxidized to form copper 2 plus ions. So we will expect the copper metal to form copper 2 plus right over here. And this copper will be defined as the anode because oxidation happens. So we define this as the anode. So the anode is where oxidation happens, and the copper, since the copper oxidized, copper metal, the copper atoms oxidize to form copper ions. So we say that oxidation happens, and this is the anode. And right over here at the silver, where the less reactive metal is, reduction happens. So what happens is that the silver ions right over here in the solution will actually move to this cathode to form silver metal. So what we can expect is that there will be a larger mass of silver forming right over here. And right over here at the anode, we can expect the copper to be smaller in size. So after the reaction, we can see it become smaller in size. So this is what happens with this when we have two metals connected together. And for this setup, no battery is needed because this reaction is actually exothermic. So if this is exothermic, that means energy is released from this reaction. So we can actually register a voltage or potential difference between the two metals because actually energy is actually given out. So the coppers, so one side and another side, they have a difference in potential. So we can actually see a reading using a voltmeter. And right over here, the salt bridge. The salt bridge is there because to actually maintain the balance of charge. So if we can look at this copper 2 sulfate solution, the Cu2 plus will be present in the solution. So you will expect, let's say we don't have the salt bridge now, we can expect there will be a higher concentration of Cu2 plus right over here. So the whole beaker over here will be more positively charged. So this cannot happen because of the conservation of charge. So what happens is that the anions over here, the NO3 minus, will actually move up the salt bridge and enter this solution right here. So this is what happens. So there will be a balance of charge. So the NO3 minus anion will be here to actually neutralize the positive Cu2 plus ions over here. And right over here, since Ag plus silver ions are actually reduced at the cathode, we will know that there's a lower concentration of Ag plus. So there's a lower concentration of positive cations. So what will happen is that in the salt bridge, the cations in the salt bridge will actually move inside here. So in the salt bridge, they normally contain K plus potassium cation. So the potassium cation will actually move in over here. Yep, so there's a balance of charge. So for this whole setup, we can actually detect potential difference. And this is actually what happens in a battery. So energy is actually released in a battery. So this reaction is exothermic. Okay, so electron flows through the external circuit from the more reactive metal, which is the copper, and and a place where oxidation happens, to the less reactive metal at the cathode. So because the negative charge electrons flows from the negative to positive, this means that the anode is the negative electrode, while the cathode is the positive electrode. Okay, so this is where confusion starts. So anode over here becomes the negative electrode. The cathode over here becomes the positive electrode, which is different from electrolysis in the earlier part of the chapter where there's a battery involved. So for this cell setup, for this setup, anode will be the negative electrode because it is where the negatively charged electrons will flow first. So, but something remains, but one statement remains the same is that anode is where oxidation happens and cathode is where reduction happens. So you have to remember this phrase very clearly so that in exams you won't be very confused. So the greater the separation of metals in the electrochemical series, the greater the potential difference that is generated in their half cell. So what is half cell is, this is actually a half cell, and this is actually a half cell. So what the reading of the voltmeter will actually be greater if we have two metals of different where the difference in the electrochemical series is actually very large. So if the position is there's a big difference in the position in the electrochemical series, then there will be a large reading of in the voltmeter. So this is what you need to know for this battery cell. So in a nutshell, the more reactive metal will be oxidized at the anode. So remember, at the anode here is always oxidation, and ions of the less reactive metal are reduced, and this will happens at the cathode, and electrons will flow from the more reactive metal to less reactive metal. So since electrons flow from the more reactive metal, which is the anode, so it will be the negative anode. And the last point that you need to know for this simple battery is that the further apart the metals are in the electrochemical series, the greater the voltage. Okay, I guess we are done with this revision of this chapter, and simply by revising is not going to help a lot. If what you need to know is actually applying what you have learned today to answer questions. So for instance, the tips that I shared with you, like oxidation always occurs at the anode, and reduction always occurs at the cathode. Using this kind of sentences that you have memorized to actually apply that to questions. So you can actually try some questions and see that are you still very confused with the concepts or not. So yeah, so this is actually you're halfway done of actually of revising for this topic. So lecture attending this lecture is actually one part to it, and you also have to try some questions during your own time. So if you have any questions regarding this topic, you can write down in the chat here, and I'll answer them. If not, I've ended my lesson here. You can actually exit from this chat. Thank you.